Today we are diving into a document that raises a disturbing question. What happens when the most important armor in a war is no longer made of steel, but invisible radio waves? Welcome to a new Strategic Labs deep dive. Check the links in the description.
Yeah, behind every destroyed tank you see on the news, or behind every visible artillery strike, there's this entirely different hidden war taking place.
Right.
It's a war fought with frequencies, signal jammers, and autonomous targeting systems. And the sources we are analyzing today, which draw on think tanks like RUSI, the RAND Corporation, and books like The Kill Chain, suggest whoever controls the electromagnetic spectrum controls the battlefield.
Okay, let's unpack this, because the whole concept of protection in warfare has been, remarkably consistent for thousands of years. It was always just about physical mass.
Exactly. From a bronze shield to knight's armor to bolting thicker steel onto a Sherman tank. It was this linear progression.
Right. The enemy gets a faster bullet, so you just build a thicker physical wall.
Yeah, the math of survival was just a physics equation, mass and kinetic energy. Even recently, with composite armor blending steel and ceramics, or explosive reactive armor, those brick-like things you see bolted onto tanks.
The ones that literally detonate outward, right?
Yeah, to disrupt incoming missiles. But the core idea was always putting dense physical matter between you and the threat. But our sources emphasize that this centuries-old equation has just violently broken down in the current conflict.
I mean, I struggle to buy this completely. Or at least I think we need to define the parameters for the listener.
Fair enough.
Because the text explicitly says steel isn't enough anymore. But look, a modern main battle tank, an Abrams or a Leopard 2, is a 70-ton beast. It's a marvel of engineering.
It absolutely is.
And we've had top attack guided missiles for decades.
Yeah.
So why are you saying all that physical protection is suddenly failing against weapons that basically look like cheap plastic toys from an electronics store?
Well, the vulnerability that physical armor has always had is that it just cannot be infinitely thick everywhere. I mean, physics and mobility dictate limitations.
You can't armor a tank like a solid block of steel.
Right. You heavily armor the front, the glacis plate, because threats traditionally came from ground level, straight ahead. But you can't put that same armor on the roof.
Because it would just be way too heavy.
Exactly. If you put 3 feet of composite armor on the top of a tank, it would weigh 150 tons. The suspension would collapse and it would just sink into the mud.
So the top is always the Achilles heel.
Always. But traditionally, top-down threats were rare and, frankly, highly expensive. Like a specialized Javelin missile costs hundreds of thousands of dollars per shot.
Which is a huge investment.
Yeah, but now, the primary threat comes from directly above, dropping with pinpoint precision into an open hatch. And it's being done by a first-person view drone, an FPV, that costs maybe $500.
Wow. And, if you've ever flown a cheap commercial drone in your backyard, you basically understand the mechanics here. People hear military drone, and they picture this massive MQ-9 Reaper firing a Hellfire missile. But an FPV drone used in trench warfare is so much simpler. It's an RC vehicle, really.
It's literally built from commercial, off-the-shelf hobbyist parts, a carbon fiber frame, 4 electric motors, a battery, and a flight controller.
And a crude explosive duct tape to the bottom. But the most important part is that it relies on a continuous live video and radio link to a human operator miles away, right?
Yes. That continuous tether is the single most important detail in this entire paradigm shift. These FPV drones are not autonomous. Well, not yet anyway.
So they can't think for themselves.
No, the flight controller only knows how to keep the drone level. It needs a human brain processing the visual information and human hands on the joysticks in real time.
So it's essentially a flying, highly lethal extension of the operator's nervous system.
Which creates a glaring inherent vulnerability. If you can disrupt that signal tether, if you can just snip that invisible wire of radio waves, the weapon is completely useless.
It just drops out of the sky.
Yeah, or the operator's screen goes to static, leaving them blind. The drone clashes or drifts off. You don't need to shoot the drone down with a billet if you can blind and deafen it electronically.
And that brings us to electronic warfare, or EW. It's a term you see in the news constantly, but the actual mechanics rarely get explained.
Right, because it sounds like magic, but it's just physics.
It's the weaponization of the electromagnetic spectrum. So break down how these EW systems actually sever that link.
Well, imagine the radio link between the drone and the operator as 2 people trying to have a conversation across a crowded room. The operator is giving quiet, specific instructions.
Okay, I'm picturing it.
Jamming is basically someone hauling a massive stadium loudspeaker into that room, placing it right next to the drone, and just blasting pure, unadulterated white noise.
So the signal isn't bouncing off a physical wall. The drone is still technically receiving the signal.
Yeah, but it's completely buried. It's a signal-to-noise ratio problem. The drone hears the quiet instructions, but it's drowned out by the deafening electronic roar of the jammer.
That makes total sense, because the operator might be 3 miles away, so their signal is weak by the time it reaches the drone.
Exactly, that's the inverse square law. But the tank being targeted has a jammer sitting just a few feet away from the drone. It wins purely due to proximity.
It's fascinating. And the sources detail other tactics too, like spoofing, right?
Oh, spoofing is wild. Instead of just blasting noise, an EW system broadcasts fake satellite signals. So if a drone relies on GPS, the jammer overpowers the real weak satellite signal.
So it tricks the drone's navigation system.
Right, it tells the drone it's suddenly in the middle of the ocean, or it messes with the altitude data so it plunges right into the dirt.
So modern warfare has literally transformed into a battle for bandwidth dominance. If you control the frequency, you survive. If not, your steel armor won't save you.
That is the exact reality. And because of this desperate battle for bandwidth, the physical look of tanks has radically changed.
Oh yeah, they look bizarre now. If you look at footage from Ukraine, these tanks are covered in these striking, often crude-looking metal cage structures.
With massive antennas jutting out everywhere.
Right. Improvised electronics, thick bundles of wiring. They look like something out of Mad Max. And it's funny because initially, Western observers heavily mocked these. They called them cope cages.
Which was a massive miscalculation by those observers. The sources we are digging into demand a complete reevaluation of those structures.
So they aren't just a psychological comfort blanket for terrified crews.
Not at all. They serve a highly technical dual purpose. First, there's the kinetic aspect, how anti-tank weapons actually work.
Let's explain that, because most people think a missile just blows a hole with a huge explosion. But it's actually about shaped charges, right? The Monroe effect.
Yes. Inside the warhead is a cone of metal, usually copper. The explosive detonates and focuses that energy, turning the copper into a superplastic jet of molten metal traveling miles per second.
Which just punches right through the steel.
But, and this is key, for that jet to form correctly, the warhead must detonate at a very specific distance from the armor, the standoff distance.
Ah, so if it hits the cage first...
It detonates too early. The explosion triggers against the cage several feet above the hull, which disrupts the formation of that molten jet, drastically reducing its penetrating power.
Okay, so the cage is literally calculated geometry. But the second purpose is even more crucial to the invisible war, right?
Absolutely. The second purpose is that these cages provide the vital structural real estate to mount heavy EW equipment.
Right, because you can't stuff all that inside the crew cabin.
No, you need jammers, omnidirectional antennas, cooling units. They have to be mounted externally with clear lines of sight.
So the tank has gone from being a rolling bunker to a heavily armed mobile Wi-Fi router of doom.
That is exactly what it is. The tank actively projects its own localized electronic shield. It is fundamentally an electronic warfare platform now.
But that has to create engineering nightmares. A tank's engine wasn't designed to run a cell tower.
Oh, it's a huge problem. Jammers require immense electrical power, so engines have to run at higher OPMs just to generate the electricity, which creates a massive thermal signature.
Making it light up on an enemy's infrared camera like a bonfire.
Right. You fix one vulnerability and create another. But physical mass is no longer the primary guarantor of survival. It must be paired with electronic resilience.
Because if you have the thickest armor in the world but no jammer, a $500 drone will destroy you.
Exactly. And the crazy thing is, once these tanks started projecting these electronic shields, the drone operators didn't just give up. They adapted.
Yeah, and this is where the speed of this new arms race just blows my mind. Because if a tank jams a 2.4 gigahertz frequency, which is basically what your home Wi-Fi uses.
Right, because the military uses cheap, off-the-shelf civilian parts.
So the FPV drone hits that wall of noise and crashes. But how long does it take the drone operators to counter that?
In the Cold War era, designing a countermeasure would take years. Writing requirements, prototyping, testing. Today, the adaptation cycle happens in days or weeks, sometimes hours.
Wait, really? How is it physically possible to redesign a weapons core communications architecture over a weekend?
Because it's completely decentralized. The operators and workshop engineers, Literally just desolder the radio receivers and swap them out for modules running on 900 megahertz or 5.8 gigahertz.
Frequencies the tank isn't currently jamming.
Exactly. They 3D print new antennas and rewrite the open source firmware overnight.
Which is crazy to think about. It's like pushing a software update to your phone, but for a lethal weapon. You find a bug, write a patch, and by morning, your drone bypasses a multi-million-dollar jammer.
That is what theorists call civilian speed. The military-industrial complex moves at bureaucratic speed, but this war is moving at civilian tech industry speed.
So if we look at the Strategic Labs analysis on this, it basically turns the battlefield into a Darwinian technological ecosystem.
That's the perfect way to phrase it. The side that survives isn't the one with the bigger industrial base or more expensive platforms. It's simply the side that adapts the fastest.
Because your tank only survives if its jammer software is newer than the drone's flight software.
Right. If they capture an enemy drone, analyze its new frequency, and push out a jamming update faster than the enemy can switch again, they win that cycle.
Which makes concentrating your forces terrifying. This hyper-fast adaptation and constant drone presence has fundamentally broken traditional military doctrine, hasn't it?
Completely. We are witnessing the death of Blitzkrieg. For 80 years, military doctrine, whether it was Soviet deep battle or American air-land battle, was about momentum and mass.
Right. Victory meant concentrating heavy armor. You mass your forces to punch a hole in the enemy line.
But that relied on a huge assumption, that you could assemble thousands of vehicles without the enemy knowing until it was too late. You relied on the fog of war.
But today, the fog of war is gone. Concentrating armor is basically a death sentence. Why is that?
Because of the transparent battlefield. You have persistent overlapping aerial surveillance 24/7, commercial drones feeding live, high-definition thermal video back to command centers.
Total sensor saturation. Plus, they use Starlink and satellite internet to share those coordinates instantly across the entire sector.
Exactly. The kill chain latency is down to minutes or seconds. So if a commander lines up an armored battalion in a tree line, they are spotted instantly.
And then precision artillery and waves of FPV drones just systematically hunt them down. So what are armies forced to do instead?
They are forced into extreme decentralization and dispersion. Instead of 30 tanks rolling down a highway, you have single, isolated vehicles creeping from tree line to tree line.
Hiding under thermal nets, employing strict emission control.
Yeah.
You have to shut off your radios so you don't get geolocated.
Right. Our sources draw a compelling historical parallel here. They compare this paradigm shift to cavalry charging machine guns in World War I.
Or battleships becoming obsolete after aircraft carriers showed up in World War II. The apex predators just become high-value targets.
Yes. But as effective as this electronic warfare cat-and-mouse game is, the text points to a terrifying new threshold that renders jamming completely useless.
Okay, here's where it gets really interesting. Because up until now, the intelligence of the weapon was the human operator miles away.
Right.
But what happens when you introduce autonomous terminal guidance? When the drones start thinking for themselves?
This is the AI threshold. Using computer vision and machine learning, modern drones can now visually identify vehicles and track them without human input.
So how does that work mechanically for the operator?
The human pilot flies the drone to the general area. Once they spot a tank on their video feed, they use their controller to draw a digital bounding box around it.
Like the yellow box on a smartphone camera when it finds a face.
Exactly. From that millisecond forward, the drone's onboard processor takes over. It uses edge detection and contrast analysis to lock onto that silhouette.
And it continues to track it even if the tank realizes it's being targeted and starts driving erratically.
Yes. It calculates the vector and dynamically adjusts to intercept. And crucially, it executes this final attack run even if its radio signal is completely severed.
Let me make sure this is crystal clear for the listener. If I'm in a tank and I fire up my massive EW jammer, flooding the spectrum with deafening static,
The drone still hits you. Because the drone is no longer listening for a signal, it's using its own internal optical sensor and processor. It completely ignores your electromagnetic noise.
So if jamming doesn't work, what happens? Because that sounds like an unsolvable problem.
The sources call this a strategic nightmare. It removes the biggest bottleneck, which is the need for highly skilled human pilots.
Because if the drone drives itself for the kill, you don't need a one-to-one ratio of pilots to drones.
Right. You could have one operator launch a swarm of 50 autonomous hunter-killer drones. The AI handles the target identification and the kinetic strike.
The battlefield just becomes saturated with these semi-autonomous weapons. It completely blurs the lines between a drone, a guided missile, and a robotic soldier.
And the economics are brutal. If you can build 10,000 autonomous drones for a few grand each and destroy $10 million tanks, the economic math of warfare collapses.
Which naturally brings us to the big debate. With AI drones hunting autonomously, does this mean the era of the tank is officially over? Is the tank dead?
It's the most fiercely debated topic right now. But the nuanced view from RAND and RSI is no. Heavy armor isn't extinct.
Because militaries still desperately need protected firepower and mobility, right? You can't hold physical ground with a drone.
Exactly. A drone can destroy a bunker, but it can't sit inside it and hold the line. You still need heavy mechanized forces. However, a tank can no longer survive alone.
So what does the future survival ecosystem look like for armor?
It requires a layered electronic ecosystem. First, active protection systems, or APS, miniature radars that detect projectiles and fire a shotgun-like blast to destroy them midair.
But those run out of ammo quickly against a drone swarm.
Which is why the next layer is directed energy weapons. High-energy lasers mounted on armored vehicles.
Wait, actual lasers?
Yes. They can instantly blind optical sensors or burn through plastic airframes at the speed of light. And they have a virtually infinite magazine depth, assuming you have the electrical power.
That sounds like science fiction, but it's a physical necessity now.
And you pair that with AI defense software that constantly analyzes the spectrum and deploys rolling, adaptive EW bubbles that move with the column.
So the tank is just the armored center of a highly complex air defense network.
Exactly.
Let's pull back for the final big picture takeaway. What does this mean for global military power?
The core thesis is that we have shifted from industrial warfare to algorithmic warfare. Software defeats steel, code overcomes kinetic mass.
Signals act as armor.
Yes. The future superpower isn't the one forging the heaviest tanks. It's the country that can perfectly integrate AI, semiconductors, drones, and rapid adaptation EW systems.
It's a hidden war of frequencies that just completely changes how we have to view global conflict from now on.
It really does. Which leaves us with the exact question the military theorists are wrestling with today. Do you believe tanks will become completely obsolete like battleships? Or will new electronic and directed energy defenses restore armored dominance?
We've reached the end of this analysis. If this added value, please like and subscribe to Strategic Labs. See you next time.